Today on the On.net show, we're going to be talking with the Docker folks about how they've made Docker work in WSL 2 to make your container experience better. Tune in. Okay, welcome to another episode of the On.net show. So today we're lucky to have two employees from Docker. And so we're going to be talking about how Docker is targeting WSL 2 in future versions of Windows. So Ben and Simone, how about you introduce yourselves and then we'll get into the topic.
So I'm Ben, I'm the product manager for Docker Desktop.
Yeah, and I'm Simon, I'm a software engineer for Docker Desktop as well.
Okay, awesome. I use that product like literally every day, so thank you. Okay, so what are we talking about?
So today we're talking about a new version of Docker Desktop, which we're looking to release sort of in the next week or so, so aiming for the end of July, which will be Docker Desktop consuming WSL2 or using WSL2 to run the Docker daemon on Windows.
Okay, now just remind me, I think WSL2 isn't shipping until next year with 20H1. So if you install this new version on, say, Windows 1903, I assume magic isn't going to happen. It only lights up when you install it on 20H1, is that right?
Yeah, that's correct.
Okay, makes sense.
So it's for us, it's a tech preview as well. So we're releasing it sort of as a limited preview for people to get playing with if they're using the insider build. They get some early feedback on how it works and to start getting some of that benefit from WSL2.
Right, so will you go to a special link to get this, or will it be on the normal Windows download page?
So there's a beta sign-up page at the moment, or a preview sign-up page. And then during sort of the end of probably October timeframe, we'll be releasing this, or September timeframe, we'll be releasing this to all Docker Desktop Edge users as well. So then everyone will get it at that point. Makes
sense. So we're talking about WSL 2, but there's a WSL 1 that's obviously already in market that people can use. So why isn't it that Microsoft and Docker didn't decide to do this earlier? What's magic about now?
So WSL 1 was an impressive effort to emulate the Linux kernel on top of Windows, but there are quite sort of foundational differences between the way the Linux kernel works and the way Windows works. Docker relies quite heavily on the Linux kernel behavior at quite a low level, and that made it quite hard for us to actually do the implementation of Docker on WSL 1. We rely on things, for example, like IP tables to surface our networking, and that support wasn't there in WSL 1. So instead, the way Docker Desktop works today is we ship a lightweight Linux distro, which just makes use of Hyper-V to run that VM on the desktop and provide that native development experience.
Right, so my understanding is with the new WSL 2, there's going to be a different VM. So is the idea that, I was just in Hyper-V doing some other stuff just earlier today, and as I've seen before, there's this Moby thing that's there, which is basically where all of my Linux containers are running. So once you move to WSL 2, will that Moby VM not be there anymore?
No, it won't be there anymore. Actually, the VM that backs the WSL 2 doesn't appear in Hyper-V. It's a very low-level construct in the OS.
Right, so I guess one of the value propositions of this is Docker then just uses the kind of provided in the box real Linux VM that you can use for everything. You can use it for Docker as well, and Docker as like a software provider doesn't have to kind of go out of their way to deploy a second Linux. You just get to use the one that's there, and it's fully featured enough to do everything you need.
Exactly, and as it's the same Linux OS that runs also all your WSL distros, we also can enable a very good degree of integration between your Linux tools and the Docker daemon as well.
Cool. So do you think, for the most part, the folks that I think about are obviously .NET developers, there are other developers on the planet as well. Will they perceive much of a difference by using Docker through WSL2, or will it mostly be the same thing, kind of just delivered a better way, or both?
So there are two categories of improvements. So for current developers using Docker Desktop today, which have Windows-based build scripts and things like that, it will just be an incremental improvement. But we also introduced a new feature which we call Linux workspaces, which enables you to use the daemon from a WSL terminal or from VS Code remote to WSL, and that's also enables many performance improvements, mainly related to I/O performance, and we'll show that in a moment.
Okay. Awesome. Anything else you guys want to talk about before we get into the demos?
No, I think we're going to run through some examples of some of the advantages you get from the WSL2 version. So I think we'd like to show them.
Okay, awesome. Let's take a look.
Yeah, so when you install Docker Desktop with WSL2 on a Windows Insider build, you'll get this WSL2 tech preview entry in the menu, and it will let you start or stop the daemon running on WSL2. And as you can see, compared to the tens of seconds that it takes to run the current Docker Desktop, it's pretty fast. It's a run.
Yeah. Oh, sorry. But is that a step that you would have to do regularly, or that's, you know, once you kind of configure your machine to use Docker and WSL2, then I assume you won't have to do that much.
Yeah, for the technical preview, we are not completely sure about the quality of the of the build. So what we decided to do is to keep the original Docker Desktop logic and the VM that comes with it, and we actually run the WSL2 daemon side by side with that. So if I go to my console here, I can see that it has populated a few Docker contexts. So there is still my default context, which is the Docker Desktop classic engine.
That's the Moby thing,
yes.
basically.
And this WSL context is actually running on top of WSL2. So I can easily switch back and forth between the two.
Right, so the one that has the star currently is the one that's
yes.
in use?
Yes, exactly. And I can do something like Docker context use default and get back to my classic daemon. So I think I should get back to WSL. And one first thing that I want to highlight is leveraging the Linux workspace stuff. So here I am in WSL2 in Bash, and I can just spawn Visual Studio Code. This will run code in remote mode. As you can see, it's opening remote to WSL.
So with what just happened there, you were in Bash.
Yeah.
Was that Bash hosted on Windows, or was that Bash
No,
in the VM?
It's Bash in the VM.
Yeah. So how did that happen?
Oh, so that's something.
It looked like magic to me.
Yeah, that's pure magic. It's actually WSL2 that uses a feature in the kernel, in the Linux kernel called bin format, which allows you to extend the kernel so that it can execute other types of executables. And what the WSL2 team has done is that when they recognize a Win32 executable, they automatically spawn the process on the Windows side and just plumb the stud.io thing between the Linux side and the Windows side.
Okay, so magic.
So now I'm running Visual Studio Code. It's running in remote mode, so my terminal here is actually a Linux terminal. And this demo is based on ASP.NET Core.
Right, so just pause for a minute. So right now, all this source code is back in Linux land.
Yes.
The terminal is in Linux land, so really the only thing that's in Windows right now is VS Code, yeah, the UI.
Actually, there is the VS Code infrastructure is based on two processes. One client processes, which is the UI running on Windows, and the server itself that runs the various extensions and things like that is running on Linux.
Right, makes sense.
So for this demo, what I want to do is actually build and run my application in a container and be able to continue developing it while it's running. So what I did there is I have this little start script that actually run as .NET SDK as a container, and I bind mounts my current directory inside the file system within the container. And usually when you did that before WSL2, you had to use file polling instead of iNotify events, because we used a file share for actually implementing the bind mount between Windows and Linux. But as we are actually hosting the files, my source files in Linux, we can actually disable that and have .NET Watch work with it. So if I do start .sh, let it start.
Yeah, .NET Watch Run is one of my favorite scenarios, running in a container.
Yeah, so I can browse my application, go to the about page, and let me edit something there. WSL2 is awesome. I save, and as you can see, the change has been picked up by .NET Watch. It's restarting my application, and without having to restart my container, and without having to rely on file polling, it just works. So that's something interesting. So we have iNotify support now with Linux Workspace, which it's a very new feature, very interesting new feature.
Wow, we're going to have to rethink. So I'm actually the one that you probably saw that that environment variable is set in our images.
Yes.
I was actually the one who put that there. So we'll have to rethink that going forward.
Yeah, I guess so. So next demo is actually taking this whole concept of Linux Workspace a bit further. So here I want to actually develop the Docker daemon within WSL2. So
that's a good stress test.
Yeah. So what I did is that I've cloned the Docker daemon code, and as I did before, I would just do a code dot. And the way we develop the daemon usually on Linux is actually to use a development container that contains the whole tool chain for building Golang code, as well as C code and things like that. And this development container has the additional benefit to have the exact same version of the tool chain as what we run on the CI. So that's really handy. So to start my container, I will just do a little make a call. So make bind here equal dot shell, and this will actually bind mounts my my source directory in my development container. So now this terminal is running my container in interactive mode, and what I can do is use my Linux script from my IDE running on Windows.
Sorry, you said your Linux
scripts, yes.
Oh, Linux scripts.
Linux
okay.
build scripts. So if we have a bunch of build scripts for building the binaries, testing, running integration tests, and so on. And so I will just use them like I would do on Linux, but from my IDE running on Windows, and with my daemon running on WSL2. So I made the binary. I can do make install to install the daemon, and I can actually run my new Docker-D that I just built within my development container within WSL2 from my Windows IDE.
Right, so for folks that didn't quite get all the pieces there, basically what you did is you built the Docker service, and now you're running it on Linux, and then I think you're going to connect to it.
Actually, no, I didn't
We're
plan
not
that,
going that far.
but actually we could do that. Actually, so what we are actually doing is that we are running a new instance of the Docker daemon within a container that we can, and that's the flow that we use to actually develop the daemon without impacting the developer machine.
Right. So actually, I didn't quite get that step. So when you ran Docker D, that was running in another container?
Yeah. So no, my terminal here is actually running a container.
Oh yes. Okay, I see now.
I'm within a container, and when I do Docker D here, it's actually running Docker D within this container.
Yes. So if you did the Docker context ls, that won't show up because it won't have visibility on that, unless. Although I guess if you had that correct IP address, you could somehow connect to that Docker daemon if you expose that port out of the container that it's running in?
It's actually running on a Unix socket, so
okay.
It's not visible from the exterior. But actually, we could do that. We could actually run Docker-D within this container, expose it through TCP, and connect to it using from the Windows CLI. It will just work.
Right, but obviously the main thing you're trying to prove here, other than these details that I'm asking about for curiosity, is that as a Docker developer using the Go tool chain for presumably quite large code base, you were fully successful. Like there was nothing that you had to do to make everything work. It just worked.
It just worked.
Okay, awesome.
And that's fantastic. And the association between WSL2, the fact that we can run the daemon on top of that, and it's accessible from Linux, and VS Code remote to WSL is just mind-blowing in terms of user experience.
Right. So, one of the things we talk about sometimes internally is, is Windows compelling as a dev box for just like arbitrary kind of developer platforms? And I think what we're seeing here is if your development experience works on Ubuntu, for example, if that's the dev box you chose, it should totally work on WSL too.
Yes.
Yeah, totally.
Yeah, that's amazing.
So next demo is another aspect of this Linux workspace thing. So
now we're in Windows.
Yeah. So this one is actually a performance comparison when using IO-heavy languages and runtimes. And
so for folks at home, I/O in this case is either disk usage or
disk
network
usage. And it's actually the main problem that we have is for some kind of these frameworks like PHP Symfony. The usual workflow is to bind mount your source code into a container that runs a PHP Symfony framework and tools, and execute it this way during development. The problem with this is that PHP Symfony rely very heavily on I/O performance, and for large projects, it's just not usable this way. So you have to actually run Symfony directly on your machine, and it can be kind of a nightmare for maintaining your development environment. So to give you an example, what I have here is just a very Symfony startup project, and it is Dockerized in this way, and it's using Docker Compose. So I'm doing just a Docker Compose up from there. Oh, I just forgot one thing. It's to use.
Oh, right, because this is going to be our baseline
Yes.
comparison. Yes, you did screw up.
So I'm doing my Docker Compose up, and we are going to go to this guy, and we'll just very how to say, sorry, my English is not
Crudely? This
Yeah,
is like the poor man's.
Yes, it's my
performance
poor
test.
man benchmark
Yeah.
framework. So we can see that roughly it's within 400 milliseconds or 500 milliseconds to render this really, really simple page. And that's all because of the include graph that runs in PHP Symfony. And now if I go to my WSL environment, I have the exact same demo. The only thing that changed is that in my compose file, oops, the port on which it listens is 8082.
Makes sense. So we don't conflict.
Yeah, so if I do a Docker Compose up on this one and just let it start it. And now if we go to this one, so the first render is approximately the same time, but after that, it's just an order of magnitude quicker.
Yeah, it looks like from here, like 22 milliseconds.
22 milliseconds versus 400 or something like that.
That's massive.
Yeah.
Yes, that's massive, and it's actually one of the top issues that we have today with Docker Desktop, and we are really happy to see that with WSL2 we are basically solving the issue.
Right, Docker Desktop for Windows in this particular case, right?
Yes. Yeah, totally.
So what else? The last thing that I want to highlight is that WSL2 is also quite clever in terms of resource allocation, and it gives access to the daemon to my whole machine. So if I do a Docker info, you'll see that I have access to all my CPUs and basically all my memory.
Yeah, I've actually often noticed that, which is by default you only get access to 2 CPUs.
Yes.
Yeah.
So on Windows today.
Yeah.
So it might be useful to explain why that is today and why you get access to 8 going forward. Or, I mean, it's not 8, it's the full set.
The full
Yeah.
machine.
Yeah.
Yeah, actually, so traditionally with Docker Desktop, we have struggled to enable dynamic resource allocation in a way that we were really
Happy about.
really happy about the stability and things like that. So we never switched the feature on, and the work that Microsoft did on WSL2, ensuring that it just works, makes it available for us to leverage it.
Right, so you don't have to do anything special.
No, it's WSL2 doing this. And so the very good thing is that it has a very positive impact on everything that is either CPU or memory intensive. And as an example, and so it has an impact on every Docker build or things like that. And as an example, what I want to do is to use a pretty heavy workload to highlight that. And one thing that I thought of was during the development of Docker Desktop with WSL2, I had to build a Linux kernel and build custom WSL2 Linux kernels. So, and at the beginning, I used to have to set up my machine to have the proper GCC and things like that. And it was a bit troublesome. So what I did is that I created a container image with all the tools that I need, and now I can build my kernel using a simple script. So I'm using this build in container script, which is just doing a Docker run, binding my kernel sources with my current configuration, etc., and just using this kernel builder image that I created. So if I run this script,
Right. So we're running it on WSL2
Yes.
on Windows. There's no right, and
So
it's loaded. This is running in your container.
Yes, it's running in a container, so it's building in a container, and as you can see,
Right. So we've pegged your CPU.
yes, it pikes my CPU. It's going to allocate quite a lot of memory.
Looks like over a gigabyte.
Yeah.
Oh,
it's
sorry, 3 gigabytes.
3 gigabytes at the moment. It might go higher. We'll see. But the main point is that it can. And
Yeah, that's the
Yeah.
point. Is,
Yes, it can do that, and
use the whole machine.
yeah, it can use the whole machine in terms of CPU and memory. And when it's done using that, it will just free up resources. So it's not completely instant. So if I interrupt the build, you'll see that my CPU has reduced, but this process is still using 3 gigs. But actually, it's just because it's just a caching, some kind of caching mechanism. And if I trigger something on the Windows side now that is kind of resource heavy in terms of memory, like building the new Windows terminal, we'll see that WSL2, when I reach some higher bounds of memory consumption, we'll see that WSL2 will begin to free up memory.
Right. So it mostly just works out.
Yeah. So the problem here is that my machine has quite a lot of memory, so we have to wait for it to really consume a lot.
So while we're waiting for that, one scenario I was thinking about is we've been using BuildKit a little bit. So that's for folks at home. That's basically the new version of Docker build. I don't think it's the default yet, though.
It's not the default.
Yeah,
yet.
I'd love it to be. But I think one of the interesting things about BuildKit is that if you use stages in your Docker file, it has the ability to detect which stages can be run in parallel. And obviously, if you have a lot of stages, then that would be interesting from the CPU standpoint. So if you've 8 CPUs and say like 20 stages, that would obviously be a lot. But you probably would see a huge
Yes.
time savings.
Yes.
Yeah, totally. That parallelization would really help.
Yeah. Have folks been testing with that, or
I have been,
Yeah.
because I have many interesting Docker build scripts that I use daily, things like Composant Kubernetes and other projects that we run in the developer solution group. And yeah, it's just a free bonus. It's
Yeah.
there is nothing to do, and it just can use all the CPUs available. Yeah.
nice. Yeah, I mean, for us, we could I could imagine, like, we could have a Docker file that builds your app, and then in parallel publishes the final version and does testing at the same time. If the publishing part doesn't rely on the output of test and just relies on the output of build, then that should all work out. Awesome.
Yeah. So my last demo is not that conclusive because
Didn't use enough memory.
Yeah.
yeah, actually I did prepare this demo some time ago, and the build process of the terminal used to use 3 or 4 gigs of memory right from the startup, and
It's not doing that now?
it seems not. But yeah, we can see that
It's a small reduction.
it's a small reduction because yeah, they somehow optimize their their build script. But yeah,
Okay, well, I'm sure the scenario is gonna be good. Because the thing that you're talking about, which is the Linux VM side releasing resources for the Windows sides to use, that would seem to be an important scenario.
Yes.
So I'm sure the team will sort that one out. Is there any other points that you guys want to make?
no, I think we're
Okay.
good.
I think other than that, we're really excited to actually keep working with WSL2, keep working with the WSL2 team, and to get this out for people to start playing with.
Yeah, so what has the partnership been like?
So we've been working with the WSL2 team sort of pretty much day on day for the last probably 2 or 3 months.
Yeah.
They initially shipped us a very early build of WSL2 by handing over a laptop to us in
Heard
Barcelona.
about that.
Yeah.
As it was the fastest way to get a build over to us, and we really wanted to start working on it to actually get this out as soon as possible.
Sounds like James Bond delivering something in a briefcase.
Yes, we call that a very modern software delivery chain. Yeah.
Yeah.
Yeah,
Well, you know, there's this old joke, which is never underestimate the bandwidth of a 747.
exactly. Exactly. It worked, and it's really helped us get going, starting work on this. So we've been feeding back into the team some ideas we've had about how to make some changes that would allow us to do even more with WSL2 on desktop, and they've been feeding back to us as well changes they think we should be making and how we should be approaching some of the further design decisions we've still got to make.
Right, so the first release should be awesome, and then there's lots of opportunities after that.
Absolutely.
Yes, things like the startup time, which is really fast. It will probably enable us to start the things more lazily, and so being more
I see.
battery saving. And
Yeah. So if I'm someone at home watching this video and I'm just super stoked about this, obviously you guys have to ship your tech preview, but let's pretend that's already happened. Then is there enough functionality in the latest 20H1 Windows Insider builds that the regular folks have access to that they could try this out?
Yes, actually, this laptop is running even not the latest
Okay.
build, so yeah,
The public ones.
it's a public one.
Yeah.
Okay. So basically the only thing left for people to try this at home is you guys publishing this tech preview.
Totally.
So how do folks get the tech preview? Yeah.
So as long as they've got the latest Windows Insider build, they can go to aka.ms/docker-wsl2 to sign up to download the latest version or the preview version of Docker Desktop, which includes the WSL2 components.
Okay. And then so once you go beyond the beta phase, then that link will just go to the official Windows, Docker Desktop for Windows, and that'll all be good. You'll just need to grab the regular one.
Yep.
Exactly.
Yeah, totally.
Okay. Well, this is a ton of value. I think people are going to be super excited by this. You know, it just builds on the WSL2 thing. You know, the combination of Docker Desktop for WSL2, WSL2 itself, and then the VS Code remote features. Just seems like developers are just going to be super happy.
Yeah, that's the goal. It's trying to make it as easy for developers to get started doing that web development on Windows as possible.
Yeah, I think the thing I like about this is it really takes advantage of using the desktop piece of Windows for, you say, Visual Studio Code like you showed, or Visual Studio, but then also the best of Linux.
Yeah.
Yep.
So,
But
okay, well, thanks for coming all this way on the show. I think you guys may be the first kind of European folks on the show that have traveled all this way, so I really appreciate it. I know my team has worked with Docker for many years, so we appreciate the partnership. And yeah, thanks for being on the show.
Thank you very much for having us.
Yeah, awesome. There's been another episode of the On.NET show today about Docker and WSL2 and all the cool stuff that's coming. Thanks.